Hi, good morning. Today we're going to review how to solve differential equation. So let's take a look at the first function that's called differential equation because you have a dy dx equal to 4x over y. Basically, differential equation is the derivative. And we're given f of 0 equal to 1. So let y equal f of x be the particular solution to the given differential equation with initial condition f of 0 equal to 1. Find y equal to f of x. So now we're going to review how to solve this differential equation. So we had dy over dx equal to 4x over y. Step number 1, always separate the variable. So the two variables are the x and y, so you have to separate the x and the y. If they give you all the variable, then you separate them. So now we use the method called cross multiply. So we're going to cross multiply. So we're going to get y times dy equal to 4x times dx. So one more time, you had to have all the same letter on one side and the other on the other side. See that y, dy, x, dx. They have to be separated. They cannot be together, okay? The y and the x is totally separated. Now next step, we're going to use the integral symbol. So now we are going to integrate. So step 2, integrate. So now we are going to look at the left side first. So we're going to have the integral y dy. So the exponent of the y is 1. So we're going to do y, 1 plus 1, and we divide by the same exponent, 1 plus 1, then divide by 1 plus 1. And then once you do this, divide disappear. Now we're going to do this part over here. So 4 stay the same. The exponent for x is 1. So you add 1 to 1. And we put plus c on the right side. Now we are going to rewrite it. Of course, you can do this in one step. Then you don't have to do this step. Okay, you can jump from here to here. Now we're going to simplify a little bit. So we get y squared over 2 equal to 4 divided by 2, you get 2, 2x squared plus c. And then next, step 3, solve for y. Because we want to solve for y, and we had the y squared over 2. So we had to eliminate the denominator first. So the denominator is 2, so therefore we times the denominator to both sides. Okay, so we are going to multiply by 2. Then here, e times 2. And this 2 and this 2 cancel out. So we are going to get y squared equal, and here you distribute 4x squared plus 2c. And we don't want to have a 2c. So we're going to pick a letter. We can use K or C. They all stand for constant. So today I'm going to use a capital C equal to 2c. Okay, capital C equal to 2c. So it becomes y squared equal to 4x squared plus capital C. We want to solve for y. So now we get y equal, remember, y squared, you get 2 branches. So you're going to be plus minus square root of 4x squared plus c. So this is called the general solution. Now, how do we find a particular solution? We have to use the initial condition, which is f of 0 equal to 1. So we use f of 0 equal to 1 to find the particular solution, x equal to 0, y equal to 1. 1 is positive. So we are going to use the positive branch. So we substitute now. 1 equal to square root of 4 times 0 squared plus c. We simplify this first. So 0 plus c is c. And then next step, you square both sides to cancel the square root. And then you get c equal to 1. Now the particular solution is y equal, you just go back to this part you had before, and you get 4x squared, and replace c by 1. So we finished finding the particular solution. Now let's go to question number 2. Question number 2. We had dy dx equal to 5y squared, and let the y equal to f of x be the particular solution to the given differential equation with initial condition f is 0 equal 3. Find the y equal to f of x. So we got dy dx equal to 5y squared. And we had the initial condition f of 0 equal 3. So now we're going to stop this one. So same idea. You are going to separate a variable. So you're going to cross multiply. So you're going to get dy times 1 is dy, 5 times y squared equal to dx. So you found that after you cross multiply, you still have a y squared over here one more time. The y squared cannot go with the x over here. Then what should we do to eliminate the y squared? So we divide by the y squared, both sides. So once we divide both sides, and then on the right side will be gone. So it becomes 5 times dx. So this cancel out. And then we get dy over y squared. Now next step, we're going to put the integral symbol. I rewrite this over because you get y squared as a denominator. Basically, it's 1 over y squared. Okay, so now you're going to prepare for integration. So we're going to write into y to the negative 2 times dy equal to integral 5 dx. Now we are going to integrate. So the exponent is negative 2. So we're going to add 1, y to the negative 2 plus 1, and then put negative 2 plus 1 equal, the derivative for 5 is 5x, because 5x have a slope equal 5, and then plus c. So now we're going to simplify a little bit. So we're going to get there is a negative 1 over here as the denominator. So we're going to times negative 1 both sides. So now we're going to times negative 1. And we're going to times negative 1. So the negative 1 and negative 1 will be cancel out. This cancel out. So we get y to the negative 1 equal. And just distribute it to each. So we get minus 5x minus c. Okay, I had no more space. I'm going to rewrite over here. So we're going to get 1 over y equal to negative 5x minus c. Y to negative 1 is 1 over y. So we found out that your y is a denominator. So we learned a technique is we're going to make the right side as one whole fraction, and then we can flip. So now we're going to flip both fractions. fractions. On the left side is one fraction, the right side is another fraction. So we get y over 1 equal to 1 over minus 5x minus c. In other words, y equal to 1 over negative 5x minus c. This is the general solution. So after we get this, we have to find the particular solution. So we're going to use the alpha 0 equal 3. X equal to 0, y equal 3. Now we're going to substitute into this. So we got 3 equal 1 over negative 5 times 0 minus c, and we solve for c. 3 equal, this becomes 0 minus c is negative c. So there are more than one way to solve over here. Okay, so we're going to use the regular way. So cross multiply, 3 times negative c is negative 3c equal to 1. And then divide by negative 3 both sides. And then I get c equal to negative 1/3. So very last step, your particular solution. This is your general solution. You use it. You get 1 over negative 5x negative c. So it has to be negative 1/3. So that means you got negative 5x plus 1/3. So that is your final answer. So we finished question number 2. Let's take a look at question number 3. Question number 3. dy dx equal to negative x times y squared over 3. Find the particular solution y equal to f of x that satisfies f of negative 2 equal 5. So now we have the initial condition is x equal negative 2 and y equal 5. So we're going to begin with dy dx equal to negative x y squared over 3. So definitely the first step should be cross multiply. But I don't want to multiply the 3 over here because I want the 3 on the right side with the x. So therefore I'm going to just multiply the dx to this side. Okay, so I'm going to have let's just multiply it to this side. And I still have a y squared over here. That was the idea. Now I'm going to rewrite a little bit. And then I'm going to divide y squared both sides. So now I get 1 over y squared times dy equal to negative x over 3 times dx. Now do you see why I keep the 3 over here? Because it's much easier to do with this, and I have a negative exponent. Now I'm going to do integral y to the negative 2 dy equal integral negative 1/3 times x dx. When you have x over 3, it means 1/3 times x. X over 2, it means 1/2 times x. So when you have this one, you just have negative 1/3 times x. Now we are going to integrate. So negative 2 plus 1, negative 2 plus 1. And negative 1/3 stay the same. The exponent for x is 1. So there will be 1 plus 1. 1 plus 1 is 2. So we divide by 2 plus c. So simplify a little bit, y to the negative 1 over negative 1. And now I'm going to get negative 1/6 times x squared plus c. and I'm going to eliminate the -1 because I want to solve for y. So I'm going to times -1 and times -1. Now this cancel out, I got y to -1 equal, and this multiply out. So you're going to get positive 16x squared minus c. And we're going to rewrite this into a fraction. 1 over y equal to 16x squared minus c. I got a one fraction, but this one is not one single fraction. Not a single fraction. So I cannot flip now. So what I do? I had to make it into one complex fraction. 1 over y equal to 16x squared minus c over 1. This is a 6, so I times 6 and times 6. So I got 1 over y equal to 16x squared minus 6c over 6. 1 over y equal to, now I have the common denominator 6, 1x squared, so it will be x squared minus 6c. Now I have one fraction equal to another fraction. Once I get this, that means I'm ready to flip. So I'm going to let k equal to 6c before I keep using the big C. So now I'm going to use k. So 1 over y equal to x squared minus k over 6. And now we're going to flip. So y equal to 6 over x squared minus k. I'm almost there. So this is my general solution. So next step, we're going to find a particular solution. So we have the f of -2 equal 5. So I'm going to make y equal to 6 over -2 squared minus k. So that means 5 equal to 6 over 4 minus k. And then we cross multiply. 5 times 4 minus k equal to 6. So I get 20 minus 5k equal to 6. Minus 20. Negative 5k equal to -14. And k equal to -14 over -5. That means k is 14 over 5. So my particular solution, now I'm going to substitute k by 14 over 5. Y equal 6 over x squared minus k. K is positive 14 over 5. So this will be the answer. Since we are not going to have multiple choice, so for a free response question, I can just leave it like this. So we finished question number 3. Let's take a look at question number 4. Question number 4. So we are going to find the particular solution, and we have the initial condition that is y equal to 3 equal to -2. So now we are going to begin. So we got dy dx equal to x squared over y, and y of 3 equal to -2. The only difference is you see y of 3, so still mean x equal 3, y equal to -2. Now we're going to solve this. So this one, you cross multiply, it will work already because there's not much over here. So y times dy equal to x squared times dx. And we're going to put the integral. So the exponent of y is 1, so 1 plus 1 is 2, so divide by 2. And then you use exponent 2 plus 1 is 3. So it's x to the 3rd power over 3. And then plus c. Now I want to eliminate the 2 over here. So to eliminate the denominator 2 times 2. So I times 2. Now I'm going to cancel this. So I get y squared equal. So now I'm going to distribute this. So I get 2x cubed over 3 plus 2c. And I can let k equal to c or big C equal to c, doesn't matter. So I'm going to get k equal to 2c. So y squared equal to 2x cubed over 3 plus k. Because of y squared, so we got 2 branches. Now we are going to use initial condition. We got y of 3 equal to -2. This is negative. So we had to use the negative branch. Now we do substitution one more time because it's negative y. So we have to use a negative branch. So you got -2 equal to negative square root of 2 times 3 cubed over 3 plus k. Because they both are negative. So now I'm going to divide both sides by negative. So divide by negative, divide by negative. So you get 2 equal positive 2 to the 3 cubed over 3 plus k. They both are negative. So you divide by negative from both sides. So now you get positive equal positive. Now simplify. So now you got 2 times 3 to the third, 27 over 3 plus k. Simplify it. Okay, so we got 2 equals square root of 18 plus k. To cancel the square root, you square both sides. So now I got 4 equal to 18 plus k minus 18. So we got k equal -14. So very last step. Because we use the negative branch, so you have to copy the negative branch. So you get 2x cubed over 3 and plus k. K is -14, so minus 14. So we finished the question. Y equal to negative square root of 2x cubed over 3 minus 14. Now let's go to question number 5. Number 5. Find the general solution for the differential equation. So we got dy dx equal to y squared times sine x. So same thing, cross multiply, in other words, you multiply the dx here. And I do not want the y squared with the x together, so I divide by y squared both sides. So now I have 1 over y squared dy equal to sine x dx. And then I put the integral symbol.